Hi guys, so in this video we're doing momentum problems, so you are more than welcome to pause the video and attempt the problems by yourself. Right, now let's start with Q4. Q4. Before we start, we have to read the question statement because it is important to understand what is the problem. Right, so a teacher demonstrates the principle of conservation of linear momentum using two trolleys. Now, the teacher first places the trolleys A and B some distance apart on a flat frictionless horizontal surface, as shown in the diagram below. The mass of trolley A is 3.5 kg and that of trolley B is 6.0 kg. Now, the reason of why they say frictionless horizontal surface is, remember, the teacher herself or himself is trying to prove the principle of conservation of linear momentum. Now, in order to prove it, you have to have a vacuum like surrounding whereby there's no influence from friction or any other factors that may affect the apparatus of our experiment. Right, so it's important to have a frictionless horizontal surface and in order to maintain constant variables. Trolley A moves towards trolley B at constant velocity. The table below shows the position of trolley A for time intervals of 0 0.4 seconds before it collides with trolley B. Alright, so we've been given the data. It's heading, it's the relationship between position and time for trolley A, and we can see that this is the data of trolley A. Right, now what is the first question? 4.1. Use the table above to prove that trolley A is moving at a constant velocity before it collides with trolley B. Now, in order to prove that, you have to know the formula for velocity. Now, the formula for velocity, it's V, it's equals to change in x over change in t, right? The displacement over time. Now we know that we've been given the position of the displacement. You can either choose any part that you want, but know that you need to have the initial and the final. So if I use the 0 0.6 as the final and 0 0.4 as the initial, and when I subtract both of them, I'm gonna get 0 0.2. So it's no use. Let's just use the 0 and the 0 0.2. So the final is 0 0.2 minus the 0 and divided by the time, which is 0 0.4 minus 0, and the final answer should be 0 0.5 meters per second. So this is the final answer that they want. So this means that um, the velocity here, it's constant, so we've proved it, meaning if you even do on the other, maybe if let's do with this one for those who have used the 0 0.4 and 0 0.6, change in x over change in t, and we know that 0 0.6 minus 0 0.4 over 0.2 minus 0 0.8, the final answer you should get 0 0.6 minus 0 0.4, it's 0 0.2, and 0 0.2 over 1 point. This one, our answer is what? 0 0.5, meaning that the velocity is constant. But you don't need to do two methods, you just need to choose between the other. You can either use A or B, right? Yeah, but please don't write two answers, two methods, because you know the memorandum, so just save your time. Right, now let's come to 4.2. They say state the principle of conservation of linear momentum in weights. Like I said, if the examiner asks us a question to define it or state it or whatever, he or she will ask us in the next question to apply what we defined, right? So keep that in mind, just in case if you have a tendency of forgetting or panicking in the exam room. Right, so they say stated, and like I usually do, I do not write definitions, but then what I'm going to do is say the definition. And the definition of the principle of conservation of linear momentum, it states that the total linear momentum of an isolated system remains the same. I repeat, the total linear momentum of an isolated system remains the same, right? So now coming to 4.3, which is the last question, states at time t is equals to 1.2 as trolley A collides with the stationary trolley B. Now, the collision time is 0 0.5 seconds, after which the two trolleys move off together. So they became one system, meaning they share the same VF. You have to know that. Now, the axes calculate the magnitude of the average net force exerted on trolley B by trolley A. Right? So, for this one, firstly, we have to find what is the V final that both of these trolleys are moving with, right? We have to find the V final of both A and B, right? We have to find it. We don't know it, because if we can find what is the V final that they're moving with, then we can use that V final to find the F net that B applies on A, right? So this is how we're going to find it. So like I said, if you are asked to define or state the next question, you are most definitely going to be asked to apply what you defined at the question above, right? So the sum of momentum before is equals to the sum of momentum after, right? And afterwards we can say A, this is A, um, V initial plus MB, V initial is equals to VF MA plus MB. This is because they moved off together, right? Good. Now remember that it is stationary. The B is stationary, so it's no need for us to calculate it, because its momentum is zero, because its velocity is zero, right? But then for this one, it's 0.5 multiplied it by the initial velocity that it had, which was 0.5. Remember, we calculated that velocity up here that trolley A was moving with. Then we can find the VF and the mass A, which is 0.5 plus 6, and your VF should be what? Should be 0.184 meters per second. Now remember that this is the velocity that both trolleys are moving with, since they became one system. Now, since they want the F net, we're going to say F net changing T is equals to changing P. For what? For trolley B. Let's just write it out. Trolley B, and voila. Then, since we know it's the F net, the time they said at what? At 1.2 seconds, right? Yeah, at 1.2 seconds. That doesn't mean that that is the change in time at that point. Basically, we're going to use this collision time, because that is the time at which the two velocities, at which the two trolleys, sorry for that, of which the two trolleys came into contact with one another. That is the time it took, right? And the collision time, right? They were coming close to each other, right? So it's 0 0.5, and the change in P, we know that they shared what? They shared the same velocity, both blocks, but then we focus on trolley B. So we're gonna write the mass and the velocities. Now remember, this is changing M, so it's M changing V. Now I'm looking for the change in velocity. I know that the initial it was 0, but the final it was 0 0.184. Right, good. Then we can divide both sides by 0 0.5, and your F net should be 2.21 newtons, right? Yeah, you can also double check, but then this is the correct answer. Right, and if ever you don't understand what's happening in this side on the change in V, please don't be confused. Remember that we're focused on trolley B, so we took the mass of trolley B. If it was the case of the force exerted by both blocks on each other, whereby we would need to use to add up the two masses and then consider the final velocity. So it's mostly, it depends on what type of question you're asked. So please bear in mind and read that question carefully. Alright guys, so let me check first that we're done, but then yeah. So we have reached the end of this video, and I hope that you understand. If you have any inquiries, please leave them below or email me if you want assistance or help. Just like that guys, I will see you guys in the next one.